Okay, now I've applied the conductive capacitive voltage boosters localized right there. The phase wires are localized under here. For the voltage booster, I have it right there to the two cathodes to attach to the electrode. Behind the electrode is a nickel neodymium, and on the nickel neodymium is rested on a copper surface, copper sheet like this, and it's bearing a winding coil alongside it. When the voltage, the current passes through the voltage booster and transmits also electrolyzing the coil. However, but the two repulsive, where this is aluminum, this is iron, and the copper is right behind. When these join together, it causes a repulsive force because of the magnets that is on the repulsive side, and because of the phase point of the wire, which allows it to move away from the magnetic field. So once it touches, going forward in reverse like a transducer, once it touches, I'm going to have also an unnatural return, where I'm going to use a rubber band to return it back to the segment. So we'll tase the front, tase it, and create electromagnetic pulse, and this will send a direct current charge to force it back to repel force to electrolux and electroflux, the winding energy to repel against the common magnet. So the common magnet will move up into the ear. So as many times it strikes against the surface, it will cause a leap or hang time. The radiation pressure, meaning acoustic driven, will keep striking it to repel. As in the past video, where I took a permanent magnet and I moved it close to the vector of another permanent magnet, whereas the common side repelled and moved away from the magnetic field. So as this returns back mechanically to strike against the surface, causing an electrolux boost more than the magnetic field of repulsive force when it moves while the magnet is in vector. This is permanently within vector. So what's going to happen is it's going to open. The magnet is going to move away from the magnetic field. So what's going to happen when it tases, it's going to force the magnet in a different direction to move upward. The more it moves upward, being in a horizontal plane, it's going to move this way, up into the ear. So using ultrasonic driven capacitor. So while I drive the capacitor, I'm going to be driving the phase wires. So I get every time the capacitor is going to be solid charge, but the phase wires of the motion of the electromagnetism switching between the phase point of the helix coil. So pancake coil to allow it to attract and repel. And I'm also going to be using a rubber band to cause it to attract together and to strike and force itself away through its own electrical energy of repulsive force. Now here, the whacking shall also synchronize the induction coil. So I'm also going to be running a transformer. And this is going to be running on a rubber, actually on current, and the electrorhythm through acoustic-driven electromotive is going to pass it like a transformer to increase the voltage to boost. So I could use a coin battery, and a coin battery set, which is 3 volts, using 2 packs, which will be 12 volts, which is 2 per unit of the coin battery. So I'm going to place that on the side because I do have the composites for that. And it's small enough for me to fit my head within the metric system. And it's not heavy. So the pulse, if my calculations are correct, I should be able to get 1,000,000 volts out of 1,000,000 volts strike force. So 1,000,000 volt strike force of repulsive force. However, I'm going to add another repulsive magnet on the top of the frame, where I probably have to make an indentation within the interface and use a permanent magnet on the side of the interface. So I'll be right back. Once I finish with that part mechanically, then I couple that into the frame. So I recreate the internal structure and use the piezo buzzer for the nose and stuff like that, and for the oxygen, and for the lip guard and bottom lip guard, and the cheek cockpit rest. So once I incorporate the flying mechatronics part of it, then I'll add the other parts. So I'll be back. My name is Jermaine Morton. Goodbye.